Memcached is a general-purpose distributed memory caching system. It is often used to speed up dynamic database-driven websites by caching data and objects in RAM to reduce the number of times an external data source must be read. Memcached is free and open-source software, subject to the terms of the revised BSD license. Memcached runs on Unix-like and on Microsoft Windows. To build it, use AutoConf, AutoMake, GNU Build System and LibEvent. Memcached's APIs provide a giant hash table distributed across multiple machines. When the table is full, subsequent inserts cause older data to be purged in least recently used order. Applications using Memcached typically layer requests and additions into RAM before falling back on a slower backing store, such as a database. The size of this hash table is often giant. It is limited by available memory across a large number of servers in a data center. Where high-volume, wide-audience web publishing requires it, this may stretch to many GB. Memcached can be equally valuable for situations where either the number of requests for content is high, or the cost of generating a particular piece of content is high. Memcached was originally developed by Danga Interactive for LiveJournal, but is now used by many other systems, including Macospace, YouTube, Reddit, Zynga, Facebook, Orange, Twitter, TUMBLR and Wikipedia. Engine Yard and Jalestic are using Memcached as part of their platform-as-a-service technology stack, and Heroku offers several Memcached services as part of their platform-as-a-service. Google App Engine, AppScale, Microsoft Azure and Amazon Web Services also offer a Memcached service through an API. History: Memcached was first developed by Brad Fitzpatrick for his website LiveJournal, on May 22, 2003. It was originally written in Perl, then later rewritten in C by Anatoly Voroby. Software architecture: the system uses a client-to-Euro-server architecture. The servers maintain a key Euro value associative array. The clients populate this array and query it. Keys are up to 250 bytes long and values can be at most 1 megabyte in size. Clients use client-side libraries to contact the servers which, by default, expose their service at port 11211. Each client knows all servers. The servers do not communicate with each other. If a client wishes to set or read the value corresponding to a certain key, the client's library first computes a hash of the key to determine the server to use. Then it contacts that server. This gives a simple form of sharding and scalable shared-nothing architecture across the servers. The server will compute a second hash of the key to determine where to store or read the corresponding value. The servers keep the values in RAM. If a server runs out of RAM, it discards the oldest values. Therefore, clients must treat Memcached as a transitory cache. They cannot assume that data stored in Memcached is still there when they need it. Memcached, Couchbase Server and other database servers provide persistent storage while maintaining Memcached protocol compatibility. If all client libraries use the same hashing algorithm to determine servers, then clients can read each other's cached data. A typical deployment will have several servers and many clients. However, it is possible to use Memcached on a single computer, acting simultaneously as client and server. Security: most deployments of Memcached exist within trusted networks where clients may freely connect to any server. There are cases, however, where Memcached is deployed in untrusted networks or where administrators would like to exercise control over the clients that are connecting. For this purpose, Memcached can be compiled with optional SASL authentication support. The SASL support requires the binary protocol. A presentation at Black Hat USA 2010 revealed that a number of large public websites had left Memcached open to inspection, analysis, retrieval, and modification of data. Even within a trusted organization, the flat trust model of Memcached may have security implications. For efficient simplicity, all Memcached operations are treated equally. Clients with a valid need for access to low-security entries within the cache gain access to all entries within the cache, even when these are higher security and that client has no justifiable need for them. If the cache key can be either predicted, guessed or found by exhaustive searching, its cache entry may be retrieved. Some attempt an isolate setting and reading of a Memcached service may be made in situations such as high-volume web publishing. A farm of outward-facing content servers have read access to Memcached containing published pages or page components, but no write access. Where new content is published, a request is instead sent to content generation servers that are not publicly accessible to create the content unit and add it to Memcached. The content server then retries to retrieve it and serve it outwards. Example code: note that all functions described on this page are pseudocode only. Memcached calls and programming languages may vary based on the API used. Converting database or object creation queries to use Memcached is simple. Typically, when using straight database queries, example code would be as follows. After conversion to Memcached, the same call might look like the following. The client would first check whether a Memcached value with the unique key user ID exists, where user ID is some number. If the result does not exist, it would select from the database as usual, and set the unique key using the Memcached API add function call. However, if only this API call were modified, the server would end up fetching incorrect data following any database update actions. The Memcached view of the data would become out of date. Therefore, in addition to creating an add call, an update call would also be needed using the Memcached set function. This call would update the currently cached data to match the new data in the database, assuming the database query succeeds. An alternative approach would be to invalidate the cache with a Memcached delete function, so that subsequent fetches result in a cache miss. Similar action would need to be taken when database records were deleted, to maintain either a correct or incomplete cache. See also: PHP Fast Cache, supported Memcached, Memcache, WinCache, APC and files. Couchbase Server, Redis, Mzia, Memcached, MySQL, directly supports the Memcached API as of version 5.6. Oracle Coherence, directly supports the Memcached API as of version 12.1.3. Gigaspaces XAP, support Memcached with high availability, transaction support, Hazelcast, Cassandra. References. External links: official website, Memcached Wiki and FAQ, PHP Memcached Manager with tag support, Membase, Memcached and Ruby, Go Memcached, Memcached implementation in Go, Quick Cached, Memcached server implementation in Java, Memcached client for AOL server, Memcached implementation on Windows 8/8.1, commercially supported distributions. Couchbase Server offers a Memcached bucket type. Gigaspaces Java-based Memcached, Hazelcast Memcached clustered, elastic, fault-tolerant, Java-based Memcached.